All right, today we continue our discussion of piecewise functions. And so our learning goals are looking very similar to what we had in 2.7 Part 1. We want to be able to graph piecewise functions, including this time step functions, which we did not talk about the first time. Second learning goal, I can write equations of piecewise functions based upon their graphs. So that's the same learning goal, but we're going to be applying it with the new type of piecewise function that is called a step function. Here's your definition for step function. It is a type of piecewise function whose graph resembles a set of stair steps. And step functions are actually the easiest type of piecewise function to graph. There's a lot less work than with the other piecewise functions that you dealt with before. And let me pull up my colors here. Hopefully we can there we go. Okay, so let's look at example 1, graph the function. So just like all the other piecewise functions, we look at the left side first and we look at the top and we say, okay, that function says y equals 1. Well, hopefully you remember from Algebra 1 that y equals 1, that is a horizontal line. If there's no x value, that means it's a horizontal line. So the horizontal line where y is 1 is right up here. Now, I obviously don't want that entire horizontal line. The restriction this time is a sandwich, and it says that I want the part of that horizontal line between when x is -4 and when x is -3. So I'm going to go to where x is -4, and that's supposed to be a closed-end dot. And I'm on my horizontal line where y is 1. When x is -3, that's an open circle. And again, I want the part of y equals 1 that is between those two values. So I'm just going to color it right between. Now, if you are a person who prefers to draw the entire thing and then erase, then go right ahead on your axes, draw your entire line of y equals 1 like this, and then make your dots at -4 and at -3 and then erase what you don't need. On step functions, I almost always do it the other way because I think that they're easier to graph, and so I don't really usually have to do the erase method on this one. But you can do whatever works for you. So let's look at the second function. It says y equals 2. So that's another horizontal line. So where y is 2 is just one step up from the last one. If I look at the restriction, it's also a sandwich, a closed circle where x is -3, an open circle where x is -2, and shading in the middle. Last one, y equals 3. So again, one step up, still a horizontal line, closed circle where x is -2, open circle where x is -1 with the shading between. So you can see why it's called a step function. It does look like a little set of stair steps, in this case going up. Now, B here is a review. It's a different type of piecewise function. This is not a step function, so just trying to reinforce what you learned in the first 2.7 lesson, because this stuff is a little bit tricky. So we look here, and my first part says y equals 3 plus x. Well, y equals 3 plus x, remember, is the same as y equals x plus 3 if you need it to be in slope-intercept form. So my slope there is 1, that's the number in front of the x. My y-intercept is 3. So that means I'm going to go, and I'm going to use a light color here because I'm going to have to use the erasing for this. So I go up to where my y-intercept is 3, and I go for a slope of 1, so up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, so on and so forth. So you can see here that along this green, that's where the entire line y equals 3 plus x would be. Now again, I don't want the whole line. I have a sandwich here that tells me I only want the part of the line where x is -3. So I go on my x-axis to find where x is -3. That's right here. So I'm going to make a big dot right there because I'm going to keep that one, and it's closed because of the equals. And then it goes up to when x is 0, which would be right here. And that one is going to be an open circle. So open circle right there. And I'm going to want the between. Now I'm going to use a darker color here to put the part that I actually do want to keep on there so that the green becomes the part that I don't want. So here's my open circle because we're ignoring the green and just looking at the red. And there is the part of the line 3 plus x that is between those two breaking points. So I have graphed y equals 3 plus x for x between -3 and 0. So now, next I want to graph y equals -1. So that looks like a horizontal line. If x equals 0. Now this is the first time we've had an equals on the restrictions. All the other ones have been some variation of a less than or greater than symbol. If you have an x equals restriction, that means that that is going to end up being a single point. Because what that's saying is graph me when y is -1 and x is 0. So all that means is the point 0, -1. So I just graph that point. It's obviously filled in since it has an equal. So 0, -1 is right down here. So I've got my little single dot right there. And that's all that the second part of this piecewise function is. So now move on to my last one, y equals -x minus 3. This one I need my slope, which number in front of the x is -1. My y-intercept is -3. So again, I'm going to start with the green here. So I go down 3 on my y-axis. And a slope of -1 means down 1, right 1. Because remember, negative slopes should fall to the right. So that's what the line would look like. I only want the part of that line, it says where x is greater than 0. So I'm going to change back to my red here. I go to where x is 0 on that line, which is right here. It should be an open circle. And I want the part that's greater than. So the x values greater are over to the right side, which would be over here. And since it says greater than, we need an arrow because it continues to go on past there. So what you had new in this example was just the restriction where it says equals instead of a greater than or less than, and that hopefully helps you review what we did yesterday because the step functions shouldn't be too difficult, I don't think, for you. Okay, so that covers our first learning goal again. So graphing the functions when you've got the equations. So now our second learning goal, write the equations of piecewise functions based upon their graph. Now, on here, on your paper, you should have the dots already filled in. They weren't on my Word because Word doesn't make small enough circles to use, but that's an open on your paper. This is closed. Open here, closed here, open here, and closed here. Okay, so it wants us to write equations for this piecewise function. So when you look at it, hopefully you can see that that is a step function. We've got a stair steps, in this case going down. The one in example 1, we're going up. But step functions should be super easy to write the equations because they're all horizontal lines. So it's just f of x or y equals, and then it should just be numbers. So if we look at the top piece right here, look at that and what the y value is there. You can count up 1, 2, 3. Y is 3 right there. So that's part of the horizontal line, y equals 3. So my first one, f of x or y, you can put either, equals 3. So now all you need is the restriction. If, because you've got two dots, you know this should be a sandwich, so I know x is going to be between two things. So the x value here, and that one should stay an open circle because it's open here, so that means this should be a less than. The x value at that point, if you count over from the origin, x equals -1, -2, -3, -4. So -4 is the starting point. Then x goes up to and includes. This is a closed circle, so I need the equals underneath on this side. The x value there is -1. So when x is between -4 and -1, my y value is 3. Then it steps down after we go above x equals -1. And now this is also a horizontal line. So it's also a y equals a number, but the number there, the y value there, is 1. So f of x equals 1 if, now I just need to do my restriction. Again, on this one, I've got an open circle on the left side and a closed one on the right, so it's set up like this. The x value here is -1. The x value here is +2. And then finally, step down again to my last piece. The y value here is below the axis. It's -1. So f of x equals -1. My restriction, again, open circle on the left, closed circle on the right. The x value on the open circle is 2. The x value on the closed circle over here is 5. So your equation for the piecewise function there is f of x equals 3 if x is between -4 and -1, equals 1 if x is between -1 and 2, and equals -1 if x is between 2 and 5. And that is it.